everyone, I'm Harshit Goel and today I'm going to discuss about buffer overflow. So what is buffer overflow? So let's understand first what is buffer. So buffer is nothing but an array in programming language. It can store data according to its size. So let's understand what is buffer overflow vulnerability. So buffer overflow happens when more data is written to an array than its capacity. So causing extra data to be written outside of the array. So let's see with a real life example. Here's the box I have. So as you can see, it can hold this much volume of contents inside it, right? So if I start filling this array or box, so after a certain time, as you can see, after a certain time, after a certain limit, it will be full and it will not able to store extra products. Like if I want to store this pen or something like that, it's not get stored. Or if I want to store anything, which what happens is if I want to store this pen in this, it will not store. As you can see, it is way bigger than it is. So what will happen is that extra data, that extra content will occupy space outside of array, right? So if I don't know if you can see that, like if you see, here's our box and this is our pen. So if I have to, it will be placed outside of the array. And what happens is this occupying space is occupy this pen will occupy space by overwriting the existing data. So there is pre-existing data. Let's say there is a scale on this place where it is stored. Now this pen can could store in this. So what will happen is this pen will overwrite this data, this scale data, and it will store like this, right? So as you can see, why is this problem anyway? Why is dangerous anyway, buffer overflow? So let's understand that. As you see, it will overwrite the data, and it can be very important data that will be overwritten. So that's why it's a problem. That what is that important data? I will talk about it later. It is as simple as it sounds. For example, if we an array, let me just grab this paper. Yeah. So can you see this? I don't know. If we an array, let's say we have an array box and we can store at least four digits of four data in this. Let's say we can store 4 digits in this array, right? So let's say I stored 1, 2, 3, 4, and I want to store 5 too. So 5 will be placed outside of array. Or let's say in this event there is not any overwritten, but let's say there is a in memory. Assume this is a part of memory, right? Stack. This is called stack. So in stack there is an array which can store only 4 digits, and I instruct the computer to store 5 digits, right? So 6 digits. So let's say this is our stack, here's our array, and here is some important data stored, already existed. So we said like 1, 2, 3, 4. After 4, 5 and 6 will be stored here. So what will happen is this will be overwritten and 5 will be stored instead of D and 6 will be stored instead of in place of A. So this uh, overwritten would be a problem for us. So now you are probably wondering why this is even allowed. I mean, clearly storing 6 number in an array where only 5 number can be stored is shouldn't be something we should do. It's not something we should do, right? So That's where is the solution. That's So what is the solution? It is runtime bound checking. Everything we want to store in an array, it will check first if there is space or room for that new data in array, right? If there is no room, more data will not be stored and insertion will stop, right? And error will be reported. What is the pros and cons of this technique, this runtime bound checking? So it makes theoretically impossible for any buffer to be overflown. But at the same time, there is a performance cost uh, due to extra code running to check if there is enough room for new data, right? And to be honest, in modern languages like Python, Java, there it is already by default configured. Like as you can do buffer overflow. It is not possible in Python and Java, but in C and C++, they choose not to implement this by default. So C++ is pretty vulnerable uh, if not if proper security measures has not been taken by the programmer or the creator. So buffer overflow are classified as software bugs. You will think programmer error is the main cause of buffer overflow. If programmer doesn't do any mistake, buffer overflow will not happen, right? No, it's not that simple. Let's take an example. Um, how can I say? Uh, let's see. Let's say there is a program where there is a program where program asks the user, the normal users, to enter their name, and it will store that name, their characters of name, in an array, right? So let's say programmer make only five or six make an array that can hold only six characters of a name, right? And the user's name is larger than the six characters, like Harshit. So Harshit has, I think, seven letters. Yeah, right? Yeah, seven letters. So what will happen is my Hershey will be stored in array and T will be stored outside of an array, causing pre-existing data to be overwritten. So normally happens, often buffer overflows are notoriously difficult to find as software complexity has outgrown the capability to find bugs. There are many cases where buffer overflow had been discovered for decades. Sorry, there are many cases where buffer overflow has been discovered in the softwares that has been using for decades now. So runtime bound checking is the only possible solution, but it is a choice that comes with trade-offs, right? You can either increase your safety and decrease your speed, or maybe increase your speed and decrease your safety. So what is the damage of buffer overflow? What is the extent of damage of buffer overflow? Wait a minute. Okay, so often buffer overflows are local variables. So they are gonna be put in area of memory called stack, right? I told you before. So what happens? This is where it gets interesting. So I told you, right? It overrides the important data. What is that important data? It could be the return address. What is return address? So return address is basically the location in code that we are going back to after we are done with the current code, after executing with the current code, right? So if a program, you know that a program is executed line by line, you can say, or maybe like in order, in some order, right? So after implementing the function, or maybe you can say current code, after executing current code, it will see the return address and will go to that part of code to implement that code, right? So normally user even can't see the return address in normal programs, but with buffer overflow, there might be a chance. Sorry, I'm cold and I can't really speak well. There might be a chance return address gets overwritten. So what will happen is normally program crashes in the case of buffer overflow, as overwritten return address doesn't point to anything in the code or to a valid program instruction. But it's kind of like a package. You can imagine like a, it's kind of like a package addressed to a place that doesn't exist, like a Santa, right? But if someone is able to carefully choose the written address that is going to be overwritten in place of code they want to execute, to the place of code they want to execute. Let's say you can like, let me this type of user control buffer flow can happen when a program tries to take a user input, as I told you, but forget to check if there is enough room for, um, or maybe forget to check if buffer is large enough to hold the given name. Let's take a very good example in ATM. In ATM, there is a function, might be a function, cash out, cash out money function. So what will happen is, to cash out the money, there is a function, there might be a function, cash out money function, to cash out the money. If there is a buffer overflow in ATM and is prompt us to ask our name, if we enter the if we enter the right name to if we enter the right name to override the buffer of get name is a function that is asking you to enter your name. So if we can override the buffer of get name function with the return address of this cash out money function, right? If we give it the address of cash out money function, what will happen is ATM ATM completes ATM computers start getting our name and then executes the cash out money function, and we will be fucking rich. But of course, it is not that simple. What if there is not any pre-existing function to cash out money, right? What will happen if there is not even function exist? Doesn't any there doesn't exist any function to cash out money for security measures, you can say. Well, eventually smart people realize that you can write your own code in the buffer and then override the return address during a buffer overflow to jump back to execute the code that you have written. It could be, then you can write code to write files, maybe starting a shell, or maybe dumping passwords or anything. It is a very powerful trick actually, if uh, executed properly, and it is a vulnerability that is found even in it is a very common vulnerability that is found even nowadays too. So they were no longer limited to code that is present in the program. To conclude, let's get to the conclusion part. To conclude, whether we are redirecting the return address to already pre-existing data function, or we have our return address point back to our own custom code that we have written, it's going it simply means to control the code that has been exist that that's been executed. basically doing to computer that we want to do what you want. Okay, where is our device? Switch off this.